Okay, a compass always points in the direction of the magnetic field. So to answer this question, we just need to trace out the magnetic field of this bar magnet. So we have to understand that the magnetic field always comes out from the North Pole. So compass B will point to the right, and we continue. Okay, with the magnetic field drawn, we can see that compass A and compass D, they will point to the left because they are right in the middle of the bar magnet. And according to the direction of the field line, compass C will point downwards. So the answer should be C. Okay, in this question, sphere Y is positively charged and sphere X is neutral. Okay, so they are connected by a metal rod, so we are expecting to see some flow of electrons, and we have to come out with the final charges on X and Y. So with this we can look at the charge movement. Let's say initially X is neutral, so we draw 4 pairs of positive charge and electrons, and Y is positive, so let's say we have 4 positive charge on it. So when they are connected, the positive charge of Y will attract the electrons of X, so the electrons will flow over until a point whereby the charges are the same. So we should see 2 electrons flowing over, and we can see that now they have the same charge, which is like +2 positive charge, and on sphere Y is also +2 positive charge, and this is when the flow of electrons will stop. So at the end, the charge on X and Y should be equal and positive, so the answer should be A. Okay, in this question we are supposed to find out the change in the resistance of the lamp in a current voltage graph. So we can use the formula R is equal to V over I. So some students, they make a mistake by finding the gradient of the current voltage graph, and they take a reciprocal to find the resistance. This is not right. What we have to do is to just take the absolute value of V over I to find the resistance. Okay, let me show you how this is supposed to be done. Okay, when the current is 1 ampere, the voltage is about 1 volt. So it will be 1 ampere and 1 volt. Okay, when current is 2 ampere, the voltage is about 3 volt. So it's 2 ampere and 3 volt. When it's about 3 ampere, the voltage is about 6 volt. 3 ampere, 6 volt. 4 ampere, it is about 12 volt. So the first set of value, if you take V over I, which is 1 over 1, the resistance here, it will be 1 ohm. And for the second set of data, the resistance is equal to V over I, so it's 3 over 2, we get 1.5 ohm. Third set of data, 6 over 3, we have 2 ohm. Fourth set of data, 12 over 4, we have 3 ohm. So looking at the trend of the resistance, we see that the resistance of the lamp increases throughout the voltage range. Answer B. Okay, we have an alternating supply that is running through a diode to a resistor, and the potential difference across the alternating supply is shown here. It has a peak voltage of 0.8 volt. As the diode only allows current to flow in one direction, we are expecting to see half of the graph being cancelled out when it reaches the resistor. So either the top half or the bottom half will be cancelled out. So let's assume that the bottom half is blocked out by the diode. We should have only half the wave as shown. And next, we understand that the diode only starts to conduct when there is a potential difference of 0.6 volt across it. And we know that the voltage across the alternating supply is 0.8 volt, and the diode has to take up 0.6 volt to conduct. So the resistor will be left with only 0.2 volt. So if you look at the potential difference graph across the resistor, we are only expecting to see a peak voltage of 0.2 volt across the resistor. Okay, that will leave us with option A as the answer. And option B is wrong because the diode will block out half of the voltage, and option B still shows all the peak. So this is wrong. Option C is not right also because the potential difference across the resistor, it should be 0.2 volt. And option D shows all the peak as well. So it's not right because the diode has blocked out half of the waveform. Hence the answer is A. The reading on the ammeter is actually the total current that will come out from the battery. So to solve the reading on the ammeter, we can use the formula I is equal to V over R, and this R will be the total resistance of the circuit. So this resistance is actually made up of a parallel branch of two 6 ohm resistor connected in series with a 3 ohm. So to find out what is the resistance of this parallel branch of two 6 ohm resistor, we can use the formula 1 over RT is equal to 1 over R1 plus 1 over R2. So 1 over RT, it will be 1 over 3, and the resistance across the parallel branch, it will be 3 ohm, and it's connected together with this 3 ohm resistor. So we take 3 plus 3, total resistance will be 6 ohm. So we come back to this formula here. Total voltage is 6 volt, total resistance is 6 ohm. The current that comes out from the battery, it will be 1 ampere. Answer D.